Viewers, you're welcome to my channel. This is the second part of my video lessons on measurement, and in this video lesson I'm going to explain the measurement of the following concepts, and they include mass and length. And in this portion I'm going to explain how to read two key instruments, which include the Vernier Caliper, and then we head on to look at reading the micrometer screw gauge. So these are two key instruments which we are going to look at in the course of this video lesson, and thereafter we'll look at the measurement of time and then volume. So before I get into this video, I want to ask you guys for a huge favor. If you have been following me for some time and have been watching some of my videos, make sure you are subscribed to this channel, and if you have subscribed, do it to click on the notification bell. I make content all the time on this channel, and a lot of time you just can't keep up because there's so much stuff to do, but I don't want you to miss out on the videos I upload all the time. And I see that a greater percentage of those watching my videos are not subscribed to this channel. So right away, click on the subscription button just beneath this video and let's get started. In the first section of this video, I'm going to explain the measurement of mass alongside the measurement of weight. Now know that mass and weight are two words that most people use interchangeably or synonymously, and people have thought that mass is similar to weight or they share the same meaning. But in real sense, there's a key difference between mass and weight, and in the course of this video I'm going to expose you to that difference between mass and weight. So by way of definition, mass is the quantity of matter contained in a body. Now when we talk about quantity means how much, how many. So how much of matter, and recall that matter is anything that has mass and occupies space. So you get to see that there's a relationship between mass and matter. So matter can also be in any state. Matter can either be in the solid state, in the liquid state, or in the gaseous state. So it can exist as a solid, liquid, or gas. So how much of matter do we have in a certain body? And mass is measured in kilograms. So if you watch our previous video, we talked about the unit for measuring mass, which is kilogram. So if you look at this first bag, we have a bag containing 3 pieces of stone, and we have our second bag containing about 8 or 9 pieces of stone. So in our first bag we have 3 pieces of stone, and in our second bag we have 9 pieces of stone. So we expect that this second bag we have more mass than the first bag. So the second bag can have a mass of 90 kilogram, and the first bag could have a mass of 30 kilogram. Let's say each stone is uniform. So mass is how much of matter do you have in a particular body. Now the measuring instrument which is of importance to you, which we use for measuring mass, is called the beam balance, just as it is displayed on your screen. Now in the beam balance we can place certain mass to find out the real mass of a particular substance, or in chemistry we can make use of what we call the chemical balance. The chemical balance is used for measuring chemical substance that have very small mass, to be very precise in our measurement. So we have the beam balance for measuring mass, just as is displayed on your screen right now. Then we also have the chemical balance, which you can use for measuring mass of chemical substance that are very small. And you should know that the beam or the chemical balance works on the principle of moment. So you could be asked in your exam, what principle does the beam balance or the chemical balance work on? That beam balance or chemical balance work on the principle of moment, which we'll look at in subsequent part of our video. Moving on, we have the measurement of weight. Now what is weight? Weight is the effect of gravity on a body. You know that if you throw any object into space, that object is pulled down. Why? Due to the influence of gravitational force or gravitational pull. So we define weight as the earth gravitational pull on a body. So if I throw a ball upwards, the ball gets to a certain height and start coming down. Why will that ball descend, or why will that ball drop back to the earth's surface? Because of the effect of gravitational pull. So what does that mean? It means that gravitational pull gives us weight. So recall that gravitational pull is a force. Weight is measured in newtons, and this is one of the key difference between mass and weight. And the instrument for measuring weight is known as the spring balance, just as it is displayed on your screen. And this is one of the instruments you find among metal scavengers in Nigeria. And this instrument works on the principles of Hooke's law, which we'll discuss in elasticity in our subsequent videos. So take note, the instrument for measuring weight is called the spring balance, and it works on the principle of Hooke's law. Now, going back to our definition, weight is simply the influence of gravitational force on a body. That is why the formula for measuring weight is equal to mass times acceleration due to gravity. So remember, mass times acceleration is equal to force. That is why weight is measured in newtons, mass is measured in kilograms, and acceleration to gravity is measured in meter per second square. So weight is a type of force caused by gravitational pull on a body. So that's one of the key difference between mass and weight. In addition to the knowledge on mass and weight, there are key differences between mass and weight, which I'm going to explain in this particular section of this video. Now, most persons use mass in the place of weight, or weight in the place of mass, because they think they are similar words or synonyms for each other. But the truth is that there is a difference between mass and weight. And the first difference is that mass is a scalar quantity. Now, what are scalar quantity? Scalar quantity are those quantity that have magnitude but no direction. So let's take this as a stone. This stone can have a mass of 10 kilogram. 10 kilogram is the magnitude, but this particular quantity, that is mass, does not have a specified direction. It is neither acting north, east, west, or south. Because if I take this stone from the earth, let's say I take it to the moon, this stone can start floating. So on the earth, it might just drop down. On the moon, it might just be floating sideways. So there is no specified direction for mass. But for weight, the weight of a body is a vector quantity. Now, what are vector quantity? Vector quantity are those quantity that have magnitude and direction. So if there is a stone with a weight of 100 Newton on the surface of the earth, the weight of a body will always act towards the center of the earth. So there is a specified direction in this case. So for vector quantity, they have magnitude and direction. Secondly, mass is constant, but the weight of a body varies. So let's take a stone with a mass of 10 kilogram. So let's say this stone is on the earth, and then let's say this stone is on another planet. Recall that weight of a body is equal to mg, and g on the earth is approximately 10 meter per second square. So in this case, the weight will be m, which is 10 kilogram for the stone, times g, which is 10. So on the earth, the weight of this body will be 100 Newton. But let's say on the planet X, g is equal to 0 meter per second square. For this case, the weight will be 10, that's the mass, times g, which is 0. So this will give us 0 Newton. In this case, the body will experience a state called weightlessness. So that is why the mass of a body, either on the earth or on the planet X, will be 10 kilogram, but the weight will vary, and the weight depends on acceleration due to gravity. Thirdly, mass of a body is measured in kilogram, or the symbol is kg. Then the weight of a body is measured with newtons, the symbol is N. And lastly, the mass of a body, like we said in the previous part of this video, is measured with a beam or the chemical balance, while the weight of a body is measured with a spring balance, as displayed on your screen. In this section of this video, we are going to look at the measurement of length, particularly the measuring instrument, their uses and their degree of accuracy. But before doing that, we should understand what length is. Now, length is the extent in space, or simply put, the distance between 2 points. So let's say this is point A and this is point B. The distance between point A and point B is what we refer to as length. So now we have some key instruments like the meter rule, the vernier caliper, and the micrometer screw gauge. So the first thing we are going to look at is the uses of these various instruments. For the meter rule, which is displayed on your screen, is used for measuring things like the length of a book, a piece of paper, or a piece of wire. We use it for measuring typically short distance. For example, the length of a book is very short, or the length of a piece of wire of a piece of paper. But when we need to measure a very long distance, we then use what we call a tape rule, just as you can see on the screen. For example, the length of a football field, we cannot use a meter rule because the meter rule is so short and it has reading up to 30 centimeter or at most 100 centimeter. So for measuring something like the length of a football field, we need a tape rule. So basically, meter rule is used for measuring things like the length of a book, a piece of paper, or a piece of wire. Then the next instrument, which you can see on your screen right now, is called the Vernier Caliper. Now, the Vernier Caliper is used for measuring internal and external diameter of cylindrical objects. Things like the milk tin, we use the Vernier Caliper to either measure the internal, that's the inner diameter, or the external, that's the outer diameter of that tin or that cylindrical object. Also, we can also use to measure things like thickness of a meter rule that we talked about as our first instrument, or it can even be the thickness of a plate. Also, we can use them to measure even the diameter of a rod. So basically, thickness or diameter, we can use the Vernier Caliper. So one thing you should know is that as we move from our first instrument, which is meter rule, to our third instrument, we are using them to measure extremely small length. So the Vernier Caliper can measure small lengths that the meter rule cannot measure. Then for the micrometer screw gauge, you can see it in the name. The word micro means small. So it measures very, very small thickness or diameter. So for example, we can use the micrometer screw gauge to measure the thickness of a paper. So just imagine the thickness of paper that we can use a meter rule to measure. Just hold a piece of paper and hold it on your hand. That thickness can be measured with a micrometer screw gauge, but a meter rule cannot do that. We can also use to measure things like diameter of small ball bearing, or things like a pendulum, or even a glass lens. All these small diameter or thickness can best be measured with a micrometer screw gauge. So it is important you know what they are used for, because this is one area you could be asked questions in the exam. So it could just be asked, the length of a piece of paper or a book can best measured with what? Your best answer should be a meter rule. Or the inner diameter or external diameter of cylindrical objects like the milk tin can best measured with what? Your best answer should be the Vernier Caliper. Or if you are told the thickness of a piece of paper can best measured with what? Your best answer should be the micrometer screw gauge. So the next thing we have on our screen is the degree of accuracy. So now we have to understand what this concept, degree of accuracy, means. Now if you look at this portion, we have a meter rule. This is just a typical illustration of the meter rule. So we have graduations from 0 to 1 and so on and so forth. Now if you look at this instrument, this is 0 centimeter. there's no reading. Then if you look at this point, this is 1 centimeter. Now when we talk about degree of accuracy, it simply means the closest measurement or the smallest measurement you can get from a particular instrument. And how can we get that? If you look at 0 and 1, we have from 0 to 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one is 10. So from 0 to 1, there are 10 smaller subunits. So that's 1 divided by 10. This will give us 0.1 centimeter. So it means that the least we can measure on a meter is to the nearest 1 decimal place in centimeter. So this is 0, this is 0.1, this is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and finally 1. So degree of accuracy simply means the smallest. What we can measure is 0.1. There's no way we can measure 0.000001 because this is not achievable or cannot be measured on the meter rule. So degree of accuracy is just simply that smallest value that can be measured. So on the meter rule, we can get a degree of accuracy of 0.1 centimeter. When you convert cm to millimeter, you simply multiply by 10 because 10 millimeter is equal to 1 centimeter, and that will give us 1 mm. So hence, coming back, degree of accuracy of a meter is 1 millimeter or 0.1 centimeter. So as you keep coming down, you keep dividing by 10 because each of them is just a 10 subdivisions. Like keep dividing each of your inch by 10. So 1 millimeter divided by 10 will give you 0.1 millimeter, and 0.1 cm divided by 10 will give you 0.01 centimeter. Coming down, we divide again by 10. So 0.1 divided by 10 will give us a 0.01 millimeter or 0.001 centimeter. In this section of this video, I'm going to explain how to read and get the measurement of a vernier caliper and the micrometer screw gauge. The diagram showing on your screen is a typical illustration of a vernier caliper. And recall, the vernier caliper is used to measure the internal or the inner and the external or the outer diameter of cylindrical object, as well as thickness of plate or the thickness of the meter rule. And a vernier caliper, just as is shown on your screen, consists of 2 scales. The one above is called the main scale. So we have the main scale, and the one beneath is called the vernier scale. Now, for we to read a vernier caliper, we have to get our reading on the main scale and then our reading on the vernier scale. So 2 things will give us our final answer. So we have to get our main scale reading, and then we'll look for our vernier scale reading. And how do we get these readings? Now I'll take you through this process. Now for the main scale reading, you are going to go to your main scale and you are going to find the last graduation or the last reading before where this vernier scale begins from. So the vernier scale starts from here. So the immediate one, just the last reading before where the vernier scale begins from, is what we are going to take as our main scale reading. So if you read, this is 6, this is going to be 6.1, then this one is going to be 6.2, and the unit here is in centimeter. So your main scale reading is going to be 6.2 centimeter. Now coming down for the vernier scale, now recall that the degree of accuracy for the vernier caliper is 0.01 centimeter. So whatever reading you have here, you are going to read it as 0.01. So this is 0, this right here is 0.01, this is 0.02. But now that's not our interest. To get your vernier scale reading, you are going to find where your main scale, where this main scale and this vernier scale, where they meet or where they coincide. Now if you look at this point, you find out that this main scale meets with the vernier scale at this point, so they form a continuous line at this point. But this one right here does not meet with any, this does not meet with any. So this is the one that meet directly with the main scale and vernier scale. So now we are going to read, this is 0, this right here is 0.01, 0.02, 0.03, or rather this is 0.04, 0.05, 0.06, 0.07, and then this is 0.08. So your vernier scale reading is 0.08 centimeter. Then you are going to add up, or you are going to take the sum. Then when you add up, you are going to get 6.28 centimeter. So the reading on this vernier caliper is 6.28 centimeter. So recall, to get your main scale reading, it is the last reading just before your vernier scale. Then to get your vernier scale reading, it is where your vernier scale coincides with the main scale, and you read it as 0.01 centimeter. Then when you get it, you can add your answer. Also, you can also convert this answer from 6.28 centimeter to millimeter. How? You multiply by 10. Then when you multiply by 10, that's 6.28 times 10. This will give you 62.8 millimeter. So in your exam, you could be told to leave your answer in millimeter or in centimeter. Now moving on, we have the micrometer screw gauge on this section. So what we have here is the micrometer screw gauge. So this is a typical illustration of the micrometer screw gauge. Now if you take a good look at this measuring instrument, we have what we call a main scale, just like the vernier caliper. We have the main scale, and then we have the vernier scale again. So both instruments have a main scale and a vernier scale. So how do we read? Now reading this one is quite similar and also different from the vernier scale. Now the graduations you have up are in whole number. So this is 16. This one right here is going to be 17. This one behind it or before it is going to be 15. So we have this one right here is 14. Then we have 15. Then we have 16. Then we have 17. Then the one below is read as half. So if this is 14, this is going to be 14.5. This one up is 15. This one down here is going to be 15.5. This one up is 16. This one below is 16.5. Then this one up here is 17. Then come down, this is 17.5. Again, the last reading, this is the last reading before the vernier scale is 17.5. So the unit here is in millimeter. So your main scale reading, the main scale reading is going to be 17.5 millimeter. Now for the vernier scale, recall that the degree of accuracy for the vernier scale is 0.01 millimeter. So you are reading in 2 decimal place. So this is going to be 0.20 mm. This is going to be 0.25 mm. This is going to be 0.30 mm. So you are reading to 2 decimal place. But how are we going to get the vernier scale reading? It is that point of coincidence where this line on your main scale, this middle line meets with a certain value. So this is the value it meets with here. So this is 25. Immediately this should be 26. So this is going to be 0.26. So the point of coincidence here is 0.26 millimeter. So the vernier scale reading is 0.26 millimeter. Remember, there's a decimal point here, 6 millimeter. So then we are going to add it up. When you add it, you should get 17.76 millimeter. So this is your final answer. In converting to centimeter, you simply divide by 10. That's 17.76 divided by 10. This should give you 1.776 centimeter. So any of them is correct. In this section, we'll take a look at the measurement of time, and after which we'll look at the measurement of volume. So what is time? Time is a fundamental physical quantity, as we have looked at earlier, and it is a measure of the duration of event. By duration, we mean the interval as well, which also form part of our definition, or the time span. What does it mean? Let's say an event started by 2 a.m. and that event ended by 6 a.m. This time is the interval or the duration of this event. It means this event lasted for 4 hours. This is time. So time is the duration, how long or how short, or the interval, how many hours between them. So that's why we have several units for measuring time, and our SI unit is seconds, though we can also measure time in minutes, we can measure it with hours, we can measure it with days, even weeks, months, and years, and so on and so forth. And the measuring instrument for time are basically stopwatch and clocks. Now moving on to the measurement of volume. What is volume? Volume is simply the capacity that an object can hold. So let's say I have a rectangular or a cuboid, this one, and I have a bigger one. I expect this first cuboid to hold less water compared to this cuboid. So if the second cuboid can hold up to 5 liters of water, this should be able to hold, let's say, 2 liters of water. Now, so volume is the capacity. How much of a substance can that object hold? That is what we refer to as volume. And volume basically is measured in meter cube as the SI unit, but though we can have other units like liters, like I said earlier, centimeter cube, millimeter cube, DL, so on and so forth. Now, the volume of a regular shape. When I say regular, a regular shape is simply a shape that we know the length, the breadth, and the height. So something like this, we know the length of this object, we can tell the breadth, and we can tell the height. For a regular shape like this, we can calculate the volume as length times breadth times height, bringing our unit to meter cube if it is measured, if each of the sides is measured in meter. Then for an irregular object, that means we cannot clearly tell the length from the breadth or the height. So for such shape, we use what we call a measuring cylinder, or better, a Eureka can. So what is the principle behind using a measuring cylinder? So let's say we have a measuring cylinder and we fill it with water to the brim. So this measuring cylinder is filled with water to the brim. An irregular shape can just be a stone, something like this. When we drop this stone into this measuring cylinder, water will flow out of it. So let's say a particular amount of water will flow out of it. The volume of water is equal to the volume of the stone that we have dropped. So if the volume of water that flowed out is, let's say, 5 mils, the stone is also equal to 5 mils in volume. Or we can use what we call a Eureka can. A Eureka can is just a modification of a measuring cylinder. So it is shaped like this. There's an opening around here, then it is filled with water. Then when I drop a stone, let's say a stone into it, and there is a receiving can, water will flow out into the stone. So the volume of water that flowed out is equal to the volume of substance you have dropped. So that is how we measure volumes of irregular objects. Why? We can't tell the length from the breadth from the height, so we simply drop them in a measuring cylinder or a Eureka can. So the volume of water that flowed out is equal to the volume of the substance or that irregular shape that you dropped into the measuring cylinder or the Eureka can. Here are some practice questions to help you test your knowledge on the measurement of mass, length and time, and the various measuring instruments we have looked at in the course of this video lesson. And it is important you provide answers to this question before I provide the final answer. And the first question we have reads, the basic principle of operation of a beam balance. Emphasis on a beam balance. Remember, the beam balance is used to measure mass, and the beam balance operates on the principle of moment. So the answer to question 1 is the principle of moment. In subsequent video, we are going to look at what moment is. Moment is simply the force times the perpendicular distance. So just as you can see on your screen, that is the beam balance, and the beam balance operates on the principle of moment. The second question reads, the inner diameter of a small test tube can be measured accurately with emphasis on the inner diameter of a small test tube. Recall that the Vernier caliper is used to measure the internal and external diameter of cylindrical object. So the best answer to question 2 is a pair of Vernier caliper. Meanwhile, we use meter rule to measure length of short distance. We use micrometer screw gauge to measure extremely small thickness. Then a pair of divider is used to measure length. So it is one of your measuring instruments in your mathematical set used to measure length. So the answer to question 2 is a pair of Vernier caliper. So option B is the correct answer. Now looking at number 3, it reads, which of the following readings give the correct precision of the length of a rod using a Vernier caliper? Now if you take a close look at the options are all in centimeter. Then we have to go back and ask ourselves, what is the degree of accuracy of a Vernier caliper in centimeter? Degree of accuracy of a Vernier caliper is either 0.1 millimeter or 0.01 centimeter. Now what does this tell us? It tells us that in centimeter we must have 2 decimal places. So we are going to pick the option that has 2 decimal places. Question 1 has just 1 decimal place, but question 2 has 2 decimal places. Question 3 has 3 decimal places. Option D rather has 3 decimal places. So the answer to question 3 is B with 2 decimal places. So recall your degree of accuracy for all your measuring instruments. Then the fourth question says the volume of a stone having an irregular shape. So 2 keywords here: volume, secondly irregular shape, can be determined using, now if you remember, we said the volume of a regular shape has a known length. You can measure the length, breadth and height. For that you can simply use the formula for volume, which is length times breadth times height. But for an irregular shape we use what we call a measuring cylinder or a Eureka can. And the principle behind this is that the volume of water that is displaced is equal to the volume of that irregular shape. So the answer to option or question 4 rather is B. We use meter rule again to measure short distances, Vernier caliper to measure the internal or the inner and the outer diameter of cylindrical object. Then micrometer screw is used to measure thickness of extremely small or very precise thickness. So let's move to the 5th question. Lastly, question 5 reads, which of the following statements are true about the spring balance and the chemical balance? So the question is telling us to identify the true statement about the spring balance, and remember the spring balance is used to measure weight, while the chemical balance is used to measure mass. So they're asking us to identify the true statement about both measuring instruments. A says both are used to measure the mass of an object. So option 1 is wrong, because spring balance is used to measure weight, while chemical balance is used to measure mass. Roman figure 2 says either of them may be used. This word may tells us that we are not sure. So it's possible that both of them are not used to measure weight, whereas spring balance is used to measure weight. So option 2 is wrong, though we know that the spring balance is used to measure weight, but the word may brings about uncertainty. We are not sure. So in this case, we are so sure that the spring balance is used to measure weight. Then moving on, Roman figure 3 says the spring balance works on the principle of Hooke's law, and or why the chemical balance works on the principle of moment, and that's true. Remember, spring balance works on the principle of Hooke's law. Then chemical balance or beam balance work on the principle of moment. So Roman figure 3 is correct. Now moving on to Roman figure 4, which says change in gravity affects the reading of a spring balance. Remember, spring balance measures weight, and what is the formula for weight? mg. So g affects weight, so gravity affects weight, that is spring balance we measure. So that is true, but not a chemical balance. Remember, mass is not affected by gravity, it is only weight that is affected by gravity. And what do we use to measure weight? Spring balance. So if there is anything that changes gravity, it will affect weight, and automatically it will affect the reading of the spring balance. So Roman figure 4 is correct. So the answer to this question is C, Roman figure 3 and Roman figure 4. So friends, I hope you enjoyed this video lesson and you learned something from this video lesson. So if you haven't subscribed to this channel, don't forget to click on the subscription button just beneath this video. Also, do it to like this video, leave your comment and suggestion in the comment section of this video, and also share this video to your friends who might need this video just like you. So till you get to see my next video, do have a wonderful time.